So binomial expansion. The best way to introduce this topic is by talking the Pascal's triangle and how it can be used. So this is something I have loved, I have come to love, and I use it nearly every time I'm required to expand small expressions, such as maybe 1 plus 2, 1 plus b raised to the power 1, 2, 3, 4, 5, 6, 7, even 8. But as the power is getting bigger, it becomes a challenge. So maybe let's start with something like this. Uh, when you expand this, of course, we all know that any number raised to the power 0 is 1. So this will just be a 1. And then when we expand this, this will remain as it is, like this. When you expand this, I'll just do it my way. You can as well just expand it like this. You still get the same answer. So because I've done a bit of these expansions, it's easy for me to expand such expressions. Basically, I'm just using this same thing. So with time and a bit of practice, you should be able to expand such expressions without even any challenges. So when you expand this, this is what you get. Of course, you can expand it like this, the way you normally do if you do not have this knowledge. And then for x to the power 4, you have 1 plus 4x plus 6x cubed, squared, plus 4x cubed plus plus x to the power 4, like that. So now, how was it possible for me to expand all these within seconds without even going through this, like multiplying this by this by that, this by this? So I was basically just using the Pascal's triangle. When you look at these coefficients, you notice that they are forming some kind of a triangle. If I was to arrange them, even as they are right now, you can see that they are forming something like a triangle. This one has 1 term, this one has 2 terms, this one has 3 terms, this one has 4 terms, this one has 5 terms. So if I was to get the coefficients, remember the coefficients of the last digit is a 1. So if I was to get the coefficients, I'll have something like this. I'm just getting these numbers, so now we can get these numbers 1, 4, 6, 4, 1. So now when you take a close look at these numbers, there is a pattern. So to get the middle number, you just need to add these two. So I can add this to get this. And then you have ones here, you have ones there. So if I want to get the numbers at the bottom, I can still follow the same pattern. So if I, like I said, to get this, you add these two. And then to get this, you add these two. To get the number between these two, which is this, you just add these two. And then you write your 1. To get this one, you can add these. To get this, you can add these two. To get this, you can add these two, and so on. So if I wanted to expand something raised to the power 5, something like this, then my coefficients will be, I'll start with a 1, followed by this plus this, that's a 5. And then this plus this is a 10. This plus this, we have another 10. This plus this, we have a 5. And then at the end, you have a 1. So with this, you can go as far down as possible. We normally use this triangle to expand small binomial expressions maybe up to 6 or 7. It may not be a very nice formula to use or method to use if you're dealing with bigger powers. So let's just get the last set of coefficients, and then we can look at a few examples on how you can use this to expand these expressions. So this plus this will be a 6. This plus this, you have a 15. This plus this, you have a 20. This plus this, you have a 15. This plus this, you have a 6. Then you write your 1 there. So as you can see, the second digit will always give you the power. So from here, you have nothing there. That tells you that the power is 0. From here, you have a 1 here, so that tells you the power is 1. From here, you have a 2. That tells you that the power is 2. From here, you have a 3. That tells you that you're dealing with something raised to the power 3, and so on. So now, what if I want to expand something like, let's just make it easy, a plus b raised to the power, let's say 4. Or maybe let's start with a 2 so that you can clearly see it. So without this and without the theorem, you can just expand this by saying a plus b and then a plus b, and then you multiply this by this, you have a squared, this by that, you have ab, this by that, you have ab, this by that, you have b squared, which is a lot of work. This plus this, you have 2ab, and then so now with this method, instead of going through all this mess, you can just write your a plus b raised to the power n, and then you write your first coefficient. Since the power is 2, I'll be using these coefficients. So my first coefficient will be a 1, and then I'll write my a raised, my a will be the first variable, by the way, or the first digit raised to the highest power. So the highest power here is a 2. So this will be a to the power 2. And then I'll put my b here, and then I'll raise it to the power 0. So what is happening here is the powers of a are decreasing as the powers of b are increasing by 1, of course. So if I reduce this by 1, I should increase this by 1, so that at the end of the day, the sum of the powers is always constant. In other words, it's always a 2, because when I add this to this, I'll get a 2. So the next one will have 2 as a coefficient. So you have your 2, and then you can say a raised to the power. This is a 2, so it will reduce by 1. And then this is a 0. The power of this one is a 0, so it will increase by 1. So that at the end of the day, the sum of these two powers is always 2 in a case like this. And then plus, the last coefficient is a 1, and then you have an a raised to the power. The power of a is reducing, while the power of b is increasing by 1. So now, we don't normally write these things because these are just ones. Any number raised to the power 0 is 1. So this will simply be an a squared, because a squared times 1 is 2a squared. And then plus, this one will be 2ab, and then plus b squared. And you're done. You have expanded this in 2 simple steps. And then to expand, let's say something like this. Right now you may not see the importance, but with time and practice it gets easier. So let's say we have a plus b raised to the power something like 4. So that means you're dealing with this set of coefficients. So your first coefficient will be a 1, and then your first variable or your first term will be a raised to the highest power. Remember, this one starts with the highest power and then it reduces along the way. So that means we have a b to the power 0 here. But remember, b to the power 0 is just the 1, so you can just ignore it. And then the second coefficient is a 4, so you can say 4. And then the powers of a are reducing by 1. So this one will be a to the power, instead of having a 4, you have a 3. But remember, the sum of the powers for these two terms, this one and this and this, should always be 4. So since we have a 3 here, we need to find the number which when added to 3, you have a 4. So that number is a 1. And then you proceed. You have a 6 here. So the power of this will reduce by 1. So instead of being a to the power 3, this would be a squared, while the power of b will increase by 1. So this would be a 2. And then plus, you get the next coefficient, which is a 4. And then this power, the power of this will reduce by 1. So you have a to the power 1 multiplied by b to the power. Remember, the powers of b are increasing by 1. So this one will be a 3. So that 3 plus 1, you have a 2. 2 plus 2, that's a 4. 2 plus 2, you have a 4. This plus this, 4. 4. And then finally, we have the last coefficient, which is a 1. And then b will increase by 1. So we have a 4. And then you may not need the a here because a will be raised to the power 0, so it won't make any difference. So now a plus b to the power 4 is simply a to the power 4 plus 4a cubed b plus 6a squared b squared plus 4a plus b cubed plus b to the power 4, and you're done. So maybe we can just look at one more example where you have some numbers. So let's say I'll make it as easy as possible. Let's say we have something like 2 plus x raised to the power, I can use a 5 because we haven't used the 5. So to expand this is your a. These are your coefficients. So you can just start with your first coefficient, which is a 1. It may not even be necessary to write the 1 there. So you can say 2 raised to the power 5. And then x will be raised to the power 0 in this case, so you can just ignore it. Plus, your next coefficient is a 5, so you write your 5 there. And then the powers of 2 are reducing by 1, so this one will be a 4. And then the powers of x are increasing, so you had an x to the power 0 there, you now have an x to the power 1. At the end of the day, the sum of this power and this power should always be a 5. And then plus, you have a 10, and then 2 to the power 3. Remember, the powers of 2 are reducing, while the powers of x are increasing, so that the total is always a 5. And then you have a 10, and then you have a 2. You reduce the power by 2, you increase the power by, you reduce the power by 1, and then you increase the power by 1 for the other term, and then plus after 10 we have the 5. I'll write it here, and then 5, say 2 raised to the power 1, and then x raised to the power 4, plus the last term, which is 1, and then x to the power 5. You don't need the 2 here because 2 will be raised to the power 0 from 1. Remember, the powers of this are decreasing, whereas the powers of x are increasing by the same constant, which is a 1. And then now you can just simplify. So 2 to the power 5, this is it 32? That's an 8, 16, 32, yes. So you have a 32, and then plus 5 multiplied by 2 to the power 4, this is a 16x, and then what have I written? I meant to write 32, and then plus 10 multiplied by 2 to the power 3, this is an 8, and then x squared, plus 10 multiplied by 2 to the power 2, that's a 4, and then x to the power 3, and then 2 to the power 1, that's a 2 multiplied by x to the power 4, and then the last term is x to the power 5. When you simplify this further, you have 32 plus 80x, and then plus another 80x, and then plus 40x cubed, plus 10x to the power 4 plus x to the power 5, and you have expanded this in within a few seconds. You don't even need your calculator most of the times. Okay, so I can just give you a few problems to attempt. Let's say you have x plus 1 raised to the power 6. You can try this one out. So these are for practice. And then you also have x, let's make it a, plus if I make it 3, okay, let's just make it 3 and reduce the power to the power 4. Just try to expand these using the triangle there. So you can even make it on your own. Just start with a 1, and then you put 1s this side. You have another one there. To get the middle number, you add these two. Because you don't need anything in the middle there, you can just put a 1. You start with the 1, you add these 2, you have a 3. You add these 2, you have another 3. And then at the end, you have a 1. You start with the 1, you add these 2, you have a 4. You add these 2, you have a 6. You add these 2, you have a 4. And then you have another 1, and so on.